Let's look at some examples in vector analysis. Given the vectors m and n, find a unit vector in the direction of minus m plus 2n. First of all, we note that the unit vectors used are ax, ay, and az, which means that the Cartesian coordinate system is being used for describing these vectors m and n. To compute the unit vector in the direction of minus m plus 2n, first compute minus m plus 2n. The computation works out to be 16, 10, 4. The three-dimensional Cartesian coordinate system is isomorphic to R3 or identical to R3, and therefore these triplets, the three coordinates or the coefficients of these vectors, can be used for describing the point, the vector minus m plus 2n. Now, a unit vector in this direction, in minus m plus 2n direction, is given by dividing the vector by its norm. So the vector divided by the norm works out to be this. So A, which is this, is the unit vector in the direction minus m plus 2n. Now the magnitude of 5ax plus n minus 3m is computed by first computing this vector and then evaluating the magnitude. So once again, 5ax is this vector, this triplet, n is this triplet, and 3m is this triplet, and adding them up, we have the result as 13 minus 5 and 22, and absolute value of this vector gives me 26.04, which is the magnitude of the given vector. And to evaluate the expression, absolute value of m multiplied with absolute value of twice of n multiplied with m plus n, we insert the values given, the m vector, n vector, into this expression. The m vector is here, the n vector is here, and m plus n is here. And we evaluate the absolute values and multiply the product of the two absolute values with the vector itself, and we get the result. Second problem. Vector m extends from the origin to point 1, 2, 3, and vector n from the origin to point 2, 3, minus 2. Find the unit vector in the direction of m minus n. To compute unit vector in this direction, we need to first compute the vector itself. M minus n is first computed by using the given data, m vector minus n vector, which works out to be this value, this vector. The magnitude of m minus n is absolute value of this vector, which we just computed, which is square root of a dot a, vector dot vector. Inner product is first taken and then square root is computed, and the absolute value works out to be 3 root 3, which is 5.2. The unit vector is therefore given by m minus n divided by absolute value, which is 3 root 3. So the vector divided by the absolute value is the unit vector in the direction of m minus n. Find the unit vector in the direction of the line extending from the origin to the midpoint of the line joining the ends of m and n. So the midpoint is located at, this is the computation. So this is how we compute the midpoint of the m and n vectors. And the unit vector is then given by the midpoint divided by the absolute value of the midpoint. So that's what we compute here. The midpoint vector, which we just computed here in this calculation, divided by the absolute value gives me the midpoint, unit vector along the midpoint. The vector from the origin to point m is given to be 6 minus 2 minus 4, and the unit vector directed from the origin towards the point n is given to be 2 minus 1, 1, 2 minus 2, 1 by 3. This is the unit vector directed from origin towards the point n. This is not the point n itself, but a unit vector directed towards point n. If points m and n are 10 units apart, find the coordinates of the point n. So m bold is given to be 6 minus 2 minus 4, and n bold, the vector, is the magnitude, which is normal case n, multiplied with the unit vector, which is given to us. So m and n are vectors, have these values, n to be determined using the fact that absolute value of n minus m is 10, because it's given that m and n are 10 units apart. Now computing this n minus m and requiring the absolute value to be equal to n, we form this equation. We expand it by using the norm formula, and we get the following quadratic equation in terms of n, the value to be determined, the absolute value of the n vector. So n is computed as 11.75. Now we take the positive value of n. N has two solutions. This is a quadratic equation, so it has two solutions. We take the positive solution, and so that the n is given by this vector. This is actually the n vector.